today we're going to work on solving exponential equations and inequalities. Not much of a difference between solving whether it's an equation or an inequality. Just remember your rules for flipping your inequality symbols. So right now, first thing we want to look at is first step in an exponential equation. Well, first off, what is an exponential equation? Exponential equation is an equation, meaning there's an equal sign, where the variable is a part of the exponent. Just like we had exponential functions, the variable is in the exponent. So the whole idea is we need to get this x by itself. We've got to move everything else away from it to find out what 1x equals. So first we're going to isolate the exponential term. So I've got to get this base and this x minus 2 by itself. So I've got to dump that 20 to the other side. So plus 20. So 125 x minus 2 equals 25. Next, I've got to get rid of this base. Well, if I'm looking at an exponent, then I want to know what that exponent is. Well, we have something that asks the question, what exponent is this? So the thing we have that asks that question is logarithms. So that's where step 2 comes in. We're just going to take the log of both sides. Just like I would divide both sides by the same number or add, like we did here with the 20 both sides. If I take the log with the same base of both sides, and technically it's log of 25, but you'll see me be lazy sometimes and write it on the outside on the far right. Now we can start doing some work. We have a lot of things that go on right here. One thing I could do is make these base 125s so that I can answer the question and all that stuff. We just usually use base 10. It's the easiest thing to write down. So just log both sides. You could do natural log both sides if you want to write one less letter. It's your call. It doesn't make a difference. The important thing is this next step. We know if we have an exponent on the log value, we get to use that power property of logarithms and multiply the log by that. So what that has done for us is x is no longer part of the exponent. X is now part of this coefficient. We're used to working with x when it's being multiplied by other things. At this point, it's just happy math. Get x by itself. So that's the last thing. After we use that power property, get x by itself. So x is inside parentheses, so we dump what's causing the parentheses to be there. So we divide both sides by log of 125. Oh, we know what this should look like on the right side. That's just your change of base formula. So log base 125 of 25. And we're left with x minus 2. And how do we finish getting x by itself? Add the 2. So x is equal to 2 plus log base 125 of 25. If you do a quick change of base formula on that, since they're both powers of 5, you should get 2/3, right? 5 squared is 25, 5 cubed is 125. So we end up with x equals 8/3 as our final answer there. So that's really it for solving exponential equations. Inequalities would be the same way. Always you can go back and check, right? 8/3 minus 2 is going to be 2/3, which we had right there. So 125 to the 2/3 power should be 25. 25 minus 20 is equal to 5. So we always go back and double check like you do any equation. But that's it. Give me a second and I'll get a couple of examples up here for you guys to try. Okay, so we have 3 examples up here. Take a minute, pause the video, try to work these out and see if you can come up with solutions to each of them, and I will wait right here. Okay, let's look at this first one, see how you did. Remember, we're going to isolate the exponential term first, so that means move our 16. The fact that's an inequality does not impact anything other than if I was to multiply or divide both sides by a negative, then we would flip the inequality. But for right now, it has no impact on subtracting that 16. 35 minus 16 is 19, I believe. Yep. Next step is to take the log of both sides. So log both sides. And then we get to use our power property. So x times log of 4 is greater than or equal to log of 19. Isolate your variable by dividing by what's attached to it. So divide by log of 4. So x is greater than or equal to whatever log base 4 of 19 is. If that was a perfect, if that would actually simplify down so that it had been log base 4 of 16, something we can evaluate and get a rational answer to, a rational number to, we would do it. Otherwise, we'll just leave it as it is. So x is greater than or equal to whatever that decimal approximation has to be. So 2 and a pinch or so. Let's go on and look at the next one here. This one's a little bit different. We're going to move that 5. So I've got negative 3 to the x equals negative 45. Now, before we can take the log of both sides, we have not completely isolated that base right there. We have minus 3 to the x. It's not negative 3 to the x, it's minus 3 to the x. So because we know we can't take the log of a negative number, I can't sit here and do log of each of these because log says that the log value has to be positive because the base by rule has to be positive. So I can't do logs at this point. I've got to get rid of that negative right there. So I can just, like always, remember, because exponents go with what they're attached to. If this was supposed to be negative 3 to the x, it would have been in parentheses right there. In which case we'd have to go with a different strategy for being able to solve it. But it's just minus 3 to the x. So we're going to multiply by a negative 1 on both sides. So that our negatives cancel on both sides, and that's going to leave us 3 to the x equals 45. Now we're ready to take log of both sides. Move our exponent on down. So x log of 3 equals log of 45. Divide by the log of 3. So x is equal to log base 3 of 45. And there it is, because 45 is not a power of 3, so we just leave it as it is. And on to the last one over here. We've already got our exponential term isolated, so we're ready to take the log of both sides. So log it, log both sides. Move your exponent out front because of the power property. So the whole exponent times log of 25 equals log of 144. And then we isolate x. Move the log of 25. 2 to the x plus 1 equals. Those do not have a common base, so we'll just combine them together. Log base 25 of 144. Move your 1. Divide by 2. Clean it up. We'll do logs on the end like we do square roots typically. So negative 1 plus log base 25 of 144 all over 2. So it's just like with quadratic equations, quadratic formula, even with the completing the square. I'm going to isolate my variable over here. If I can evaluate. If I know the square root, then I take the square root. If I don't, I leave it. Well, if I know the log of that number, then I'll take the log of that number. If I don't, I just leave it right there. So that's really all there is to solving exponential equations. It's just, or inequalities. It's just isolating your variable. And when it gets time to get that variable out of the exponent, we just do log of both sides and use that power property to move that, to turn that exponent now into a coefficient. And then it's something that we are a lot more comfortable working with. That's exponential equations, and I will see you in class tomorrow, guys.